Welcome to the session. Greeting of the day. In today's class, we will see about the programmable logic controllers. We are on the talk of the various devices which is going to do a processing operations and controlling operations and modifications. So earlier we have seen about the microprocessors and microcontrollers. In continuous with that programmable logical devices, we are going to see about the programmable logical controllers, how it is done. Next we are coming into, we told PLC is a simple understanding of a programming language. That is nothing but this ladder program. This is a ladder program. A ladder program, like a C program, it is a ladder program. So say, this is the general assembly of a sketch that in the software we have to do. So few conditions are there to perform this ladder diagram. Few conditions are there to perform this ladder diagram. So this is the left, I am naming this as a left rail, left power rail. So here the power is there. Now I want to take the power from the rail, this is the rail, and I have to make the connections with respect to logic gates, and then I want to activate, this is the output line, the rung 1, this one I am calling as a rung 1, rung 2, rung 3 and rung 4, and lastly we have an ending run. So this is the power rail. From the power we have to take and we have to give to the output. We will see one by one. So vertical line is named as a power rail. Now we have seen this is the vertical line. I am naming this as a power rail. And then the horizontal line I am naming this as a rungs. So this is a rung 1 horizontal line and rung 1, rung 2, rung 3. Each rung defines one operation in the controlled process. I want to make a contact here and a contact here. If two are enabled, if two are circuit connections, here the bulb will power on. From the power, it should go here and the input A, input B to be activated like a latch switches, like a solenoids. If it is activated, the circuit again it crosses and waits here until the activation room B. Until the activation room B alarm is activated here. Alarm B is activated, then the fire engine will start here. So likewise we should program. Each run defines one operation, one output, one fire engines, one alarm, one bulb, likewise. The ladder diagram must read from left to right. Very important point. Always I am not reading from this side to this side. Power rail is in the left. I am seeing this. I want to read from left to right. And from top to bottom. I am reading from left to right. And I have to see first run 1 should complete. Then the run 2, then the run 3. The run 3 can be reconnected to the run 1 by the program. But it should start from run 1 to end run. Run 1 to end run. It cannot be able to start in the middle for run 3. You should start from top to bottom, left to right. That is the point. Some configurations. Each run must start with an input and must end with an output. Each run must start with an input and end with an output only. So input may multiply. Input A, input B are there. We just started with the inputs of 2, but one input to be there, it's a must. And it should end with an output. It should end with an output. Only one output it is there for this rung 1. And second we can able to do the second, third. So multiple inputs we can able to give, but it should contain one input, one output. Multiple inputs can be there. Only one output per rung will be there. So that is the conditions. Each rung can that's the point. Each rung can have more than one inputs, but only one output possible. So I am calling input left run, output right end of the run. Input I am giving here left end of the run, and Output I am taking from the right end of the run. So this is the power right, left to right we are reading, top to bottom we are reading. It should contain, must contain input and output, and at the left I am drawing the input, I am taking the output at the other end. So that is what the conditions to be satisfied for drawing the ladder diagram. So few conditions I have given here. We have seen timer counters, logics, how to select in the single PLC. We in the laboratories normally for the normal functions for maintenance of home appliances, so we can able to have minimum number of ports. Based upon the output, number of outputs, we can select the PLC. It means the number of input and output required, number of input and output required for this. So such cases, I want to operate a lift, I want to operate a traffic jam signal. So there are many inputs are there. So multiple inputs I needed. I want to operate single water level management on the tank at home. So it should on, it should off. High level, low level. So it is to be sensitive. So we can able to take a low level at one sensor, high level at one sensor. Two inputs are there. And output motor should on off. So such cases depend upon the inputs and outputs what the execution is there. Depend upon that I am selecting a number of inputs and outputs. How to select the PLC? So there is a number of type of input and output, maybe a analog input or digital inputs, sensors we are using, what it is. So depend upon the input and output. Memory sizes required. So large program we need more memories. So simpler program we need less memories. So speed and the power of the processors. So those things are not depend upon selection of PLC. At home appliances, normal CPU, at as like our home laptops, we are using some minimum requirement of the processors. But in the heavy industries, they are using a high-end systems. So likewise, you should select. So features and advantages of the PLC. It is able to programmable. Yes. Real-time operations. The PLC is always the PLC. Where what input we are giving, what output we are taking, it depends upon that. Maybe we are using for the experimental laboratory instruments, or otherwise we are using for the industrial to move the trolley. So those things can be programmed. So it's all real-time operations we are doing. So based upon that PLC, the real-time applications can do. The laboratory experiments can do the same PLC. Therefore, the feature it is a real-time applications only. Uses easy ladder logic programs. Yes, simple. These are the ladder programs what we have seen. It is not a C program, it is not a Java program, it is simple ladders. Inbuilt testing of easy troubleshootings. Compact and economical. So it is a compact, small and economical also based upon the setups. Fast responses and easy to expand input and output ports. So I am able to expand input and output ports with respect to single PLC kit. PLC kit contains the processor and those inputs and outputs points we can able to incorporate later according to the requirement in the able to expand. So input I am expanding, output also I can able to expand. Less cost and easy to repair are some of the features and advantages of the PLC. I want to compare this PLC with respect to our computer. How this is, both have the processors, both are having the input and outputs, mouse and printers we are connected to the computers, and same the water level sensors and functioning of motor we are connected to the PLC. How it differs with this? So ladder, it is a ladder logic program works on the industrial environmental applications. So this PLC will not get dust free or dust accommodatable, anything it works in the rough conditions. PLC is not going to spoil. But executes several programs. Yes, it executes several programs simultaneously. It also works heavily. Computer also works heavily. But in the industrial dust, if the computer is getting dust, it will stuck. It will not work. But when the program is fed to the PLC having the inbuilt memory, therefore, after feeding the program to the PLC, we can remove the computer. We don't need of attachment of computer in the industry. Feeding and we can take the PLC separately and it will work in the rough conditions. Therefore, it is can able to accommodate the dust or environmental tough conditions. Programmed and handled by low skilled workers. If we are understanding this ladder diagrams, any unskilled laborers can also program the ladder. Not like C programs, it needs skill, but ladder programs are easy. Seeing the diagrams and picking up and dragging and creating the software programs. And therefore it is semi-skilled workers are more than enough to operate the PLC. The computer requires a high knowledge persons to operate, to program the hardwares and softwares. So it is somehow the knowledge skilled persons are needed there. The ladder programs with the languages were built into permanent memory which is in the PLC itself. It requires a memory disk, hard disk we needed, somehow the C drive, D drives are there, and it has a large memories to program. So such things we can able to do there. The less flexible in terms of software, it means we cannot able to reprogram. Reprogramming done through the software and feed it to the PLC. But editings, all those things which is linked with a computer we should do. So it is something, it is not flexible, little bit not flexible, it requires attachment of computer integrated softwares. Therefore we can able to reprogram. But it is possible, reprogrammable. But it is flexibility is less. Here it is more flexible in terms of softwares. The computer itself we are programming. PLC with computer it works. But it needs computer to program in the PLC. Therefore I mentioned here less flexible. There it is flexible. PLC deals with the sensors, switches and actuators. So yes, it works with the sensors, switches and actuators, but PLC with whom it is dealing with the computers, mouses, keyboards, printers. So there it deals. PLC is going to deal with the outputs as softwares and programs and the keyboards and the mouses. So likewise, no disturbances even in power failure, because their programmer is fed to the PLC. PLC contains the memory and those memory is going to permanent memory. So even multiple times of switching on and switching off, PLC with the inbuilt program it can work. But in the computer, the loss of data happens. We are working on the Word documents, we are working on the Excel sheets. When the power failure is occurred, the Word document, what we have worked or what we have typed, it is going to loss. And we want to do it the program same day again times. So nowadays this is auto saving is there, but normally it's a loss of data will occur if I am transferring a data from one pen drive to the computers. During the intermediate time the power termination occurs, and then therefore the transfer will not occur and the loss of data will be there. So that's a point where we can able to understand that loss of data is possible there. So a few symbols also we should understand. Before going or before drawing the ladder program, we should understand few. So it is this symbol it represents. We are going to draw a program. So likewise, I have taken a left rail, power rail. From that I have connected a line. Power rail is taken. I want to switch on the bulb. So I want to make a switch connections between two, left and right, or power positive, negative, like that we can consider. So I want to make one connection. So here the power rail I am making here, this is named as normally open. It is not connected now. And it is ready, the power circuit is ready. And here I am connecting one output. So this is called as, this symbol represents the output. We are understanding the program. We are not typing the program. Through symbol we are taking and understanding. That is what I have mentioned. Easy to understand the program. So that is like this. So I am putting one output here. And I am closing. So that is what? The left run, left right, right run. So it is one of the rail connections as like this. You see? Left right, right right. From the left rail I have taken the power. On the first run I have created an open contact and one input, one output. All are satisfying, all points are satisfying here. Multiple inputs can take but only one output. Now what I am doing? Now I wanted to make the connections. I am concerned this is a bulb. I am concerned this is a fan. I am concerned this is a automatic camera. Anything, some output I should take. When this is an alarm also we can take. Some examples. So when the circuit is closed, the circuit is normally open. It is mentioned here, it is normally open. I want to close now. The switch is activated. Otherwise, due to the sensors is activated, sensor is connected to the switch, and this is activated now. How it is activated? It is connected this two. If it is connected this two, the power can go from left to the motor. Until then power not came. Until then sensor is not detected. When the sensor is detected, that sensor give the information to make a latch here, to make the connection here, and then it is connected. If it is connected, here it is power connection. The power connection now moves there. How? Now it is ready. It is stopped there. When the power is closed, and we are moving from here to here, the power is going here, and power is ready. Now it is going to activate. So now it is going to activate. This is nothing but a bulb, alarm, anything. So it is activated now. So the power is one is over. So accordingly we can do. So this is what I have drawn there. See, input and output I have taken. So when input is activated, now it can come and do. And now the other options, what I can do, other options. So I am naming this as a, I am naming this as a input and B. Now I have taken this B connections. I have already programmed. How I am programming like this? I am programming in such a way, it is in the closed contact. It is in the closed, it is normally closed. It is normally closed. What happens? This is keep on running. I am naming this as a, I have this bulb. Therefore I am naming this as a motor. Right? So when the sensor is detected, it means when the temperature sensor is detected, this alarm bulb should blink. If the alarm bulb is blinked, I have taken this output as a secondary input to the second run of B here. When this bulb is activated, the connection which is normally closed will go into disconnect. Opposite reaction should take place there. If it is open, when the sensor detected, it is closing on the circuit. This is on connection. This is off connection. This is normally closed. When the sensor is detected, this connection is going to disconnect. If it is disconnected, automatically the motors or power circuits which is going to disconnect. What happens already, according to by this design, here we have the connection is already moving here. Connection is already moving to the motor. When the bulb is activated, it is going to, it want to disconnect now. Normally closed, it is going to disconnect. How it is disconnected? This power circuit will off. The power circuit will off now. So it want to run the motor. It want to run the motor, power circuit will cut, therefore alarm, and the people will be, from the rooms we can take exit. So for therefore power terminations occurs there. So likewise simple examples we can do, and this what happens here, with what? You see? So here when it is alarm B is started, this connections will make a disconnection. If it is disconnected, what happens? Motor is going to stop. I have drawn first as normally closed. But what happens? When this B is activated, this is going to disconnect. It means the closed system is becoming the open. This is normally open. When it is circuit is on, this is going to on. This is going to on condition. This is normally, this is off condition. First it is off condition. It is going to on. Here this is generally first in the on condition. When circuit is closed, it is going to off condition. So this is the changeover occurred with respect to simple logic connections. So one by one we have to see. Normally open, output occurs when the input is given. Output is on when we have sensor is detected and input is given. That's the point. And here it is normally closed. Normally closed. Output occurs when the input is not given. I have not touched it at all. Motor has been already running. Power has been already in display. But when the sensor is detected, it is going to disconnect. And there is no supply of power there. So that is what a simple understanding we should do. So I want to give a small example of a solenoid valve is to be activated if the sensor A is given as an input. What I am doing, sensor A is activated, see sensor A is activated here. If the sensor is detected, if the low level of water tank is detected, it should activate the motor. So it can fill. And when I am connecting the second solenoid, when the solenoid 2 is activated here, it should disconnect the motor. So such examples we can able to take care. The remaining part of the subjects, we'll see you in the next session. Thank you.